Hi, hello everyone. Hope you're all doing good. So in this particular session, we are going to discuss about network topology, right? Network design patterns. In the recent times, I've seen many of them are struggling with network related troubleshooting, and people have just started their journey on the cloud where they did not get enough knowledge or enough understanding about how the network connections are established, how the devices are getting connected to each other. So there is a lot of gap there. So what I'm going to cover in this session is I'm going to cover up with the details, what are the different type of network design patterns that we have, the design topology we have got, including the most common design pattern, which is the hub and spoke in the cloud model. So we'll also understand which are the ones are currently used in the LAN, in the wide area network, WAN, internet, and so on. Right. So let's go and get better, deeper understanding. So there are different type of network. It might be physically wired, or it might be optical cabling connection, or it might be wireless radio frequency method. So there are variety of connection methods, and there are variety of design pattern that we can utilize for different customer business requirement, right? So you can configure them in a unique define design, or there are various method to combine them together in a hybrid topology as well. So we'll get to that point little later, but for now, what exactly is a network? So network is defined as a set of devices that share the resources or that can use common communication protocol over interconnecting different devices. Or in simple words, network is nothing but how we interconnect two different devices, or how we establish data communication between the devices, right? That is what the network is. So in order to have this network set up, so there are two different things. Okay, so we need to understand the physical topology as well as the logical topology. So when it comes to physical topology, we are talking about the cabling connection, the physical connections, the wireless way of connecting stuffs, the way that we establish the connections, the pattern, and all those things. So that is what the physical cabling connection is all about, or the physical topology is all about. But when it comes to logical, so there are lot of different models that are available. So we will discuss about OSI layer and the ISO OSI model, then the TCP/IP model later. But for now, when it comes to logical topology, that is where we ensure that only the required ports are open. We tune the network to achieve the maximum speed, what kind of protocols are allowed, what kind of data flow is allowed. So that is all about logical topology, right? So network topology is a term used to describe both physical as well as logical arrangement of devices on a computer network, right? So there are many ways to connect a network topology, starting from bus, mesh, star to hybrid options, right? We will see each of these options in detail. We will have the use cases understood, and then we will also understand the advantages and disadvantages of each of these network design pattern, and also we will see where exactly they are using these pattern, right? So with that said, let's get into each of the design pattern. So there are 6 different network topologies, excluding the hub and spoke model, which is a kind of a similar pattern like your star topology in this particular diagram. So we are seeing the star topology, right? It is very much similar to that, but there are some differences in a way that how star topology and hub and spoke. It's a very small subtle difference. Okay, we'll see that shortly. So let's get into the design patterns one by one. See, when it comes to an environment, right? Design is the foundation of your environment, especially the network design, the landing zone. When people talk about landing zone, network topology diagrams, the network design document is very, very crucial, because network adds visibility into your design. If there is something which you have not implemented correctly or properly, the network design diagram can help you to quickly identify the problem, because you are getting a visualized view of your environment. So if there is a risk, or if there is a weak point, or if there is a gap, you can easily go and identify it, and then you can troubleshoot it if you have a well design diagram, especially on the network topology level. So there are 7 different topologies or 7 different design patterns that we can use for different requirement. So we'll start with the ones which has been in the environment for very long time, and the ones which are currently used in the cloud environment, like the hub and spoke topology model. Right. So let's start with the basic bus topology. This is the one which has been in the um, IT environment or in the schools and colleges for a very long time. So we will have a single cable. That cable we call it as the backbone cable. In fact, the cable name is coaxial cable, right? And you have the BNC connector that will have connections for each and every systems on the network. See, if there is a problem with this backbone cable or the bus cable, they call it as, then the entire set of communications will get interrupted. But if there is a issue with one single cable that connects to a single device, or if there is an issue with single device, none of the other systems in the network are impacted. So, but then see, this cannot have a longer distance. So there is a way to improve the connections, like having repeaters and so on. But the end of the cable, you should not have a cut end. It should have a terminator instead of a cut end, right? Where that, so that, I mean, so the data will flow in a bidirectional way. It is a single collision domain. See, this single cable is used for sending the traffic as well as receiving the traffic. So it is a single broadcast domain. It is a single collision domain. And you might also hear about 10 base to 10 base something, right? So 10 base 2 means the cabling is 200 meters long. The cabling is 200 meters. So bus topology is a network configuration in which all the devices are connected to a single communication line, which is called as the backbone cable or the bus cable, or the actual name is the coaxial cable technology that we are using. So data transmitted by any device traverses the entire length of the bus, and each device receives the data packet. But finally, based on the data details, so the specific data will reach to the computer that it is destined to, right? Consider a small office, or consider a maybe lab or college or school labs. Okay, most of them might be using this bus topology, but most of the companies or most of the universities have developed these days, and this bus topology is very, very rarely used. It's almost I would say deprecated. This model, it's no more used in the corporate environment, right? So, but then it was there in existence for a very long time, but nowadays it has got moved away, right? There are benefits, there are disadvantages as well. So you can see it is very simple to set up because it is one single cable, and then you will have the BNC connectors that can connect to other systems. It is less expensive because of one single wire, and then it is only suitable for a very temporary or a small network, and the node failures will not impact the other systems in the connection aspect. But then if the single cable gets impacted, the main bus cable or the backbone cable gets impacted, then everything will go down. Okay, so you have coaxial cables and twisted pair cables used in the bus concept that can help you to achieve 10 Mbps. You remember those olden days, 20-25 years back, right? So we used to talk high on the 10 Mbps and all those stuff. But yeah, nowadays we are talking about Gbps and terabyte speed, right? So it used to be a huge amount of bandwidth those days before the internet era. Disadvantages is there is no redundancy. It's a single point of failure and the cabling level. It is a limited cable length, no security whatsoever. In IT, there is a say, right? If there is no security, then you can consider that IT environment as nothing, right? So security is important here. The spoofing or entering into this network is kind of comparatively easy, right? So if the network traffic is heavy on this particular single cable, all the systems in the network will start experiencing collisions and slowness and performance issues, all those stuff. So bus topology is no more there. It's very rarely used in the corporate environments, but it is still in usage on some remote offices and schools and colleges in developing countries, not on the developed countries, but on the remote sites in some of the countries. It is still being used. Point to point, yeah. So each devices are getting connected to point. Like it can be two different systems or two different routers. In olden days, I used to have my system directly getting connected to a printer at home, or directly getting connected to a server, or two different systems using cross cabling. So this is very common those days, like system to system connection. But nowadays it is being used on the corporate data center to data center, maybe the on-premises environment getting connected to a public cloud environment or public cloud data center using express route or direct connect circuit. So these are all two different routers getting directly connected to each other, right? So these are all examples of private or point-to-point connections where the connectivity is all secure because it is only two different systems sending and receiving the packets, where it is transmitting and receiving it. So it does not traverse to the public internet. It is a dedicated fiber cabling connection in most of the cases. It's a point-to-point. Even you can use Ethernet cables. It's not a problem, but mostly these days it is used in connecting two different data centers, and primarily it is used in connecting two different routers these days. So mesh topology, yeah, it's a there are a lot of IoT systems. For example, even at in your there is a concept in the states and even in some of the modern countries where you have a smart home system, right? Where you will have systems like security systems, smart appliances, lighting systems, thermostats, all these are connected using a mesh topology concept. So even at home network also, mesh topology is very common, but it is widely adopted in the internet, the wide area network. Whatever the earlier examples we talked about, the bus topology and all those things, those are all very common in the LAN, local area network, in an intranet. But then the mesh topology is very common and popular in WAN topology, the wide area network. See here in the mesh topology, we are every device is connected to another device via a particular cable. For example, there are 5 different devices for this particular thing, so there will be 5 cabling connection. So if you look at the numbers here, it states the same. If there are 5 devices, then there are if there are 6 devices, the number of ports that are needed is actually 5. Because like for example, if there are n number of devices, there will be in mesh topology, for example, to connect to 5 different systems, there will be 5 cables for each of the device, right? So there is a formula to calculate the number of links that is needed for the case study. Okay, so mesh topology, the communication is very fast between the nodes because it is directly connected to each other. The mesh topology is robust. It is highly reliable and fault tolerant because you have dedicated connections for each of the systems. So one cable connection might not impact the entire flow or entire system connection. So that is how the internet is connected nowadays, right? Multiple routers getting connected to each other. It's like a mesh. Okay, you can see that clearly here in this diagram, right? So the even the public cloud providers like Amazon, Microsoft, they are using this mesh topology for interconnecting their global wide area network, right? Installation and configurations are little difficult to start with, but then once you have set up it in a proper way, it is the best kind of setup that you can have. The maintenance is definitely high because you have a lot of devices involved, especially if you are setting it up for the internet backbone. You need to have a lot of redundancy and a lot of reliable connections. A lot of telecom providers are definitely using the mesh topology for connecting them. Even in the cloud, the transit gateway concept, right? The VPC peering concept, these are all developed based on mesh topology, right? And not just here, even in the military communication and even on the aircraft navigation systems, we are using mesh topology. So there are advantages and disadvantages for the mesh topology, like what I have highlighted above. But yeah, so there are a lot of use cases with mesh topology. Ring topology, it's like a bus topology, but it is in a closed loop. Okay, bus topology, it will be a single cable and both the rear ends, it will be like kind of terminators. But here you'll have repeaters and it will kind of, for example, if you have hundreds of system, then the data getting transferred over the ring, it might get slowed down. So repeater will boost the performance and also it will prevent the data loss, right? So in the ring topology, the systems are connected to two different neighboring systems, and you can also form a dual ring topology. So this is a single ring topology. You can have two rings or dual cabling connections so that you can form a dual ring topology concept. So there is a concept called token passing system. So token is being used for sending the information. So it's like a kind of, see, if you look at, if you consider the police control room, they will be sending alerts to all the devices, right? But then the specific device which needs to accept and acknowledge, the people, the person at the receiving end will acknowledge it, right? Similarly here, there is a token that gets circulated. It's a frame, in fact. So the system that is going to accept it, the station that is going to hold the token, will accept it, and they will send the acknowledgement. So there are two different type of token: early token release concept, where the token gets released just after transmitting the data. But in the other case, delayed token releases, the token will be released after the acknowledgement is received from the receiver. Like for example, in walkie-talkie, right? So they use the similar concept. So ring topology is a network configuration where each network interfaces is connected to exactly two other devices. It forms a continuous loop, right? So the data flows in this particular loop direction. It's a bus topology, but in a closed loop. Consider a small office building with several departments. They are using these kind of ring topology to connect neighboring systems, and it forms a closed loop. So let's say even you can have some devices like centralized file server or file share that can act as a centralized system for this. Even the ring topology is very common in metropolitan area network, MAN network. And historically, ring topology was commonly used in token ring networks. So it used to be called as token topology or token ring topology earlier, but people have stopped calling that name because see, earlier they used to call it because there is a token passing mechanism to access the systems or to prevent the data collision. They used to have it. So there is a low latency because of there is no intermediate switches or router. So to send the traffic, this ring topology are suitable for real-time business application that requires low latency, like video conferencing or voice conferencing systems, like walkie-talkie systems or whatever. So for those use cases, these kind of ring topologies are very common, and small to medium sized network or companies or departments, they are really using it. It can be a cost effective deployment because we are not using any high end devices and stuff. And security aspect, since the data travels in a predefined path, relatively it is secure, but definitely there is a chance of unauthorized access and eavesdropping can be done. Compared to bus topology, this is somewhat better, okay, somewhat secure and reliable and redundancy, because you can also create a dual mesh topology. But it is very less commonly used. If you compare it with star topology or mesh topology, ring topology is not that heavily used. I would say topology is also kind of diminishing, and you won't see that in the near future. Okay, like the mesh topologies and the hybrid topologies are the ones which are going to be heavily used. And the most common topology that you might see in many of the corporate offices or companies is the tree topology. So this has been in use for a very long time, right? In a local area network, you might have a centralized hub or a firewall device or an appliance that will have that will be connecting to a L3 switch or a distribution switch like a L2 switch. So people call it as core switch or core router, and then they will have for each floor, each department, they might have a separate distribution switch. And see, it's like a hierarchical or organized. I mean, it is organized in a way. It is following a hierarchical structure, right? Like maybe in a family, you can use the analogy of parent, child, grandchild, and so on. Similarly, in a I mean, you can consider these things as a leaf nodes, like a sub branch for a particular tree. That's the reason it is called tree topology. So you have a centralized management, you have options to create redundant switches and then have high availability. You can also isolate the systems. You can have a separate set of switches and systems for your non-production environment, and you can have a production environment. You can call this as a virtual LAN 10. This can be called as a virtual LAN 20, something like that. So you can have good amount of traffic isolation. You can have good amount of segmentation. So this is a kind of, each floor can have a distribution switch, and you can get it connected to a centralized core switch or a core router. That is how most of the office locations are kind of set up. right? So it's a very common topology. There are a lot of advantages, and obviously there are some couple of disadvantages as well. So the scalability is the best here because you can add any number of devices and add more switches as you want. But this is actually like they are all connected to a single central hub because it decreases the distance. Each floor might have a distribution switch, and they can act as a isolated environment. They can act as a isolated segment for each of the department. Each of the environment can be isolated, so you can form different networks. You can add any devices. Error detection is very easy in tree topology. You can identify where exactly the problem is. You can go and correct it quickly. But if the central hub fails, there is a lot of challenges here because the tree topology, the central router or the core switch acts as the kind of distribution mechanism, but the distributed switches can independently continue to work if the traffic is between the system that are connected to the departments or just within the department. Okay, if new devices are added, yeah, there are some configuration stuff that we need to take care of, but yeah, it's not that tough. Nowadays, the most common pattern is the star topology. So star topology, and maybe like there is a advanced hub and spoke topology which we are going to understand in a while. But then in star topology, if you look at here, the devices are getting connected like a star. You can see the image depicting the same. And in star topology, all the devices are getting connected to a single hub or a single switch or a cable. See, in this particular case, see, each devices are having separate connection. So this is a single collision domain. So for this particular device, the traffic will flow through a separate cable, unlike your bus topology. So in bus topology, you have a single cable and then the devices are connected like this, right? So it's a single collision domain. So this is what I'm referring to. The single cable will be used for sending the traffic and receiving the traffic for every single device on the network. But then here, each of these devices have a separate cable. So each of them are called separate collision domain. In this example, there are 5 different collision domain. If you have a 24 port switch or a 32 port switch with all the devices connected, all the cables connected, then the number of ports that are connected, they are all considered as a separate collision domain. But these are all single broadcast domain. You can send information to all the systems. You can also use this as an intelligent hub where you can send broadcasting activities using the RJ45 cables or whatever. So there are a lot of enhancements in star topology. There are many Ethernet LAN protocols that are used, like collision detection, carrier sense, multiple access, CSMA, CD. These kind of technologies are very common in star topology. In star topology, you get centralized management. That is the beauty of it. But here, advantages, if you have these many number of systems, the n number of systems, if you have 4 systems, then 4 cables are needed. If you are having 4 systems connected, you need 4 ports on the switch or the router here, right? So that's the concept here. It is robust, definitely. If one link fails, only that particular link will get impacted. None of the other systems will be impacted. It is very easy to design, maintain, install, configure, and even to find the fault, to isolate the fault. It is very easy. It is very scalable. You can add more systems as you want, and star topology is very cost effective compared to the other inexpensive models. But the problem is there is single point of failure. If this centralized hub or the concentrator or the switch fails, then there is an impact to multiple systems in the department. So you can have multiple different central hub or central devices to have single point of failure, to avoid single point of failure. So the cost of installation is high because you need to have multiple connections. If you want high availability, obviously the cost is going to increase. The performance is definitely based on the single concentrator. If there is a choke or if there is a heavy load on the central system, then it will impact all the systems that are connected. It's like a chain effect, right? So these topologies are also used in wireless network where all the systems are getting connected to the central hub. In wireless access point, there will be multiple devices getting connected. It's like a star topology again. So hub and spoke, it's pretty much similar to many people, including myself, right? So I consider hub and spoke as very much similar to star topology. People can use it interchangeably when it comes to data transmission, data transfer, but there is a subtle difference here. What is that? So in central hub and spoke model, The centralized hub also plays the role of management. It also does the centralized data management in hub and spoke. Whereas in star topology, it is a facility to just do the routing, just do the data transfer, nothing beyond that. Okay, so when it comes to hub and spoke, this is a very common model that you can see in the cloud, public cloud areas like AWS or Azure or GCP. This is a very common model, right? You will have a hub where all the business application will be configured and designed. You will have a public subnet where you'll have the web front end systems. You'll have a app subnet where you'll have the private subnet for hosting those business application layers, and you'll have the database on the private subnet. And if you want to connect these application to S3 bucket for storing the objects, or to store the tables in DynamoDB, or to send notifications securely, you can use the private endpoint or the VPC endpoint to securely connect to these products and services, so that the data doesn't go through the general public internet. It doesn't go through the internet gateway. So you can have some secure connections directly using the endpoint concept, so that the data does not go through the public internet. Instead, it flows through the Amazon or Microsoft backbone in their respective clouds. So there are different gateways that are available for connecting to the internet, or for the users to connect from the internet to the web application or to the applications. You can use the internet gateway to securely connect from your remote or branch offices. You can use point to site VPN or client VPN endpoint, or to connect from your corporate data center to AWS or Microsoft data center. You can use express route or direct connect. To connect to different site, you can use site to site VPN. So these are all spokes, right? So these are all spokes, and we have a hub here. So hubs are getting connected to multiple spokes, right? So you have spoke 1, spoke 2, spoke 3, and so on. So this is what we generally use in hub and spoke model. Generally in cloud, this is the very common model that people use. And there is one more model called hybrid cloud model, where you can have a mix of star and a ring, or bus and a ring. It depends on case to case. You can have these combinations. So whenever there is a combination of two, then we call it as hybrid. And hybrid, there are some benefits like flexibility and size of the network, whereas there are some drawbacks because the design is complex. You have to mix and match couple of concepts here, and then hubs used in the topology are really expensive because of the devices that we have at the core level. But then the ring topology, it is less expensive. So it depends, right? So how do you have this design in university campuses or colleges, schools? These kind of hybrid methods are very common. Even in some mid-sized companies, in some of the buildings, some of the floor, we might have a mesh. You might have a hub in certain areas. So it depends, right? So it is very common. Some of them will be wired, some of them will be wireless. So hybrid is very, very common these days. Okay, I'll explain about one of the wireless option to start with. For example, if you have a tablet, mobile, and a laptop which you want to interconnect, you can go for this ad hoc topology, where you don't need any additional cables, routers. There is no wireless access point, there is no server, but you will be able to connect these systems like a Bluetooth or an infrasec kind of thing using this ad hoc topology. There is one more concept. This is the most common, where if you go to the cafe shop, or even if you go to your offices or some hotels, you can see this very commonly, right? They will have a switch, and the internet service provider will have a modem setup, and then you will have wireless access point in each floors or in each areas in restaurants and hotels. Like this is very, very common wireless mesh topology. And this infrastructure topology is very common in office areas. You'll have wireless options, you'll have wired options, where you'll have a mix of switches and modems and wireless access point, which can help you to connect from your mobile devices and also from your laptops and desktops, right? This is one example of wireless. Thank you for listening. We will discuss a lot about network, and we will get familiar with the